Okay, this is on the next page of your notes, part two, so to speak, of 4.1. And if you flip the page over to here, I can't remember what page it is, page 113, there's going to be a formal definition of an absolute maximum and an absolute minimum. And really, you could read all of this in the notes if you needed to. But really, you're going to have what they're going to be talking about, an absolute max, or absolute minimum. And all that means is your highest Y value or your lowest value, depending on what interval you're looking at. So that's why they'll say for all X in the domain of F in both cases. So in other words, you'll have a certain domain that you're looking at, a certain amount of X values. And if your Y value you're finding is the highest, it'll be called the maximum. And if the Y value you're finding is the lowest, you'll have the minimum. So it's actually not that bad of a deal. And if I scroll down in the notes here, you guys will be happy because won't be so tough. Try and give me 1 second. So as I scroll down, if I ask you if there's a max or minimum on this function here on the left-hand side, this is a cubic function. And really, because this graph shoots off forever up and down, it doesn't have a max or min because in theory it's going off to infinity and off to negative infinity in this direction. So that graph there would not have any max or min values. Now something over here, notice this graph really goes on the side of the right here, on the right graph. There is no maximum value because both sides go up to infinity. However, there is an absolute minimum in this area right here, if you can look. That's why I tried to, and I'll put a different color here, say, hey, you have an absolute minimum at where X is -2. Now, I don't know what that Y value is, but because both graphs shoot up to infinity, both sides of my graph, that is the lowest point possible. That's going to be called my absolute minimum. Now, I should also introduce some I guess, verbiage. That's also called a local minimum. And really, we'll get to that formally in a little bit. But the local minimum is just meaning like, hey, this is the lowest point somewhere in here, in the local, in the vicinity of. And likewise, this is going to be a local max right here at 1. Again, a local meaning in the vicinity of. So I'm really introducing some terms really before you guys are going to get a crack at them. But so you're going to have two things to talk about: a local minimum, which this is, and simultaneously an absolute minimum because it's just coincidentally the lowest point on the graph. You have a local maximum here. It is not an absolute maximum because there are other values that have higher Y outputs because that thing goes up to infinity. And you'll get more of this as I continue. So if I scroll down, they call them absolute extrema or absolute extreme values. It depends on both your function and the interval of interest. Sometimes you'll have what they call a closed interval. And in this case, closed meaning you have the closed endpoints here at A and at B. It's continuous. So in other words, if you have a continuous function on a closed interval, you will be asked what's the maximum or minimum values. Now, when that happens, it's not too bad. But what you got to do is you can actually visually see this one in the sense that you have a feeling that your absolute maximum is there. But when you do this, it's also called a closed interval method, which will be on the next page of your notes. So that's going to be my absolute max. But you also have to remember to check the Y values of your endpoints when you do it this way. And again, we'll formally get into that later. But since I introduced that verbiage about local, this is also a local max. I apologize for the handwriting, but like I said, the best I got. So you're going to have an absolute max wherever X is C or where the input is C right here because the Y value is above not only the endpoints, but it's at the top of your graph. Now, something that we need to start paying attention to, this question right here is very crucial into what we're doing going forward. So if you have a continuous function on a closed interval but no graph, the absolute maximum occurs, if you talk about where the slope is, the slope of that tangent line is really 0. So that's why I wrote down here, it could, now it's not guaranteed, and you'll see where we're getting into this derivatives and where the slope is 0 further here. But a max or min could occur whenever the first derivative is set equal to 0. So even if you don't know the picture, sometimes you can set the thing equal to 0, and you might have a max or min there. Should be very important to note that it also could occur where your function doesn't exist, or your first derivative doesn't exist, sorry. And I'll show you an example of that in a second. So what we're going towards, we're trying to find max or min values and focusing on this, where this first derivative equals 0 or doesn't exist, could potentially be a max or min, and that's if you don't have a graph to look at. All right, next video, next page on 114.